Okay, horizontal asymptote tricks. So the first one states if the highest degree of the rational function, or the highest degrees of the rational functions are the same, so the denominator and the numerator, just find their coefficients, and the ratio will be the horizontal asymptote. So what that means is our highest degree of our numerator is x squared, and the highest degree of our denominator is x squared. So they are the same. So we look for the coefficients. The coefficients are the terms in front of them, and we find their ratio, and their ratio will give us the horizontal asymptote. So according to this trick, the ratio is 4 over 2, which means what's our horizontal asymptote? 2. Okay, let's test this. So in order to test this, we're going to find the limit as x tends to, let's say, positive infinity. Now remember, the first thing we wanted to do was find the highest degree of both the numerator and denominator, and we already have it. It's x squared, and we're going to divide every term by that. So what that means is I would have 4x squared divided by x squared, 2x divided by x squared, and 1 divided by x squared, all over. The reason we're doing this is take it out like a common factor. 2x squared divided by x squared minus 5x divided by x squared plus 5 divided by x squared. Okay. When we take out our common factor here, sorry, equal sign should be over here. As we take out our common factor, we're left with the limit as x tends to positive infinity. Okay. And we're left with x squared, and we'll have 4. Sorry, that should be a squared underneath. 4 plus 2 over x plus 1 over x squared divided by x squared again, which then gives us 2 minus 5 over x plus 5 over x squared. Now what we're going to do from here is we're going to simplify a little. Our x squared and our x squared will cancel each other out. Okay. And also what's important here, well, actually we'll rewrite it before we move on. So we're left with 4 plus 2 over x plus 1 over x squared divided by 2 minus 5 over x plus 5 over x squared. Okay, so what we're going to do now is we're going to find the limit as it approaches positive infinity. So what we're going to be doing is replacing each of our x variables in this equation with our value of infinity. I know that's not the nicest looking one. That's a little better. Okay. What that means is we're going to end up with values, no matter what's on top, divided by an infinitely large number. If we divide by an infinitely large number, what essentially are we creating?
0.
A 0. These terms are essentially just going to become zeros when we plug in our negative or positive, sorry, infinity. So we can get rid of our limit. We've applied the limit now. Is equal to 4 plus 2 divided by infinity is a 0. Plus 1 divided by infinity squared, no difference, still going to be 0. 2 minus 5 divided by infinity, still going to be 0. And 5 divided by infinity squared, still going to be 0. So in the end, we end up with our wonderful magic ratio, or horizontal asymptote, of 2. You guys are so smart. Okay. There's our first one. Our second one, correct me if I'm wrong. I don't know. If the numerator's degree is 1 higher than the denominator's degree, then the horizontal asymptote is 0. Angelique? 0? Wrong? What did I say? Oh, I wrote it wrong in the definition. The example is correct. Okay. There you go. Is 1 less than the denominator's degree? Yes, that makes sense. If it's 1 higher, we have an oblique asymptote, okay? But we're not going to talk about those. So, if the numerator's degree is 1 less than the denominator's degree, then the horizontal asymptote is 0. So, we look at the highest degree of each of these functions. We have x to the power of 1 and then x to the power of 2. Well, what that means is our numerators is 1 degree higher than our denominators. Therefore, our horizontal asymptote is 0. Let's test this theory. the limit as x tends to negative infinity. We'll still be plugging in the value of infinity, okay? And we'll talk about the negative and positive after. I'll go back and solve those. So first step we want to do is we want to divide each of the functions, the numerator's function and denominator's function, by the variable with the highest degree. Well, on top, that's x. So we're going to go 3x divided by x minus 5 divided by x. That was all right. On the bottom, it's x squared, so 5x squared divided by x squared plus 2x divided by x squared. Oh, there we go. Plus 2 divided by x squared. Okay. When we take out our common term, limit as x tends to negative infinity, we're left with x outside, and we're left with 3 minus 5 divided by x. And we're left with x squared, 5 plus 2 divided by x plus 2 divided by x squared. When we go to simplify this function, this will become a 1. This essentially will just become an x on the bottom. So the limit as x tends to negative infinity, we're left with 3 minus 5 over x. That's going to work. Divided by our term x, and then 5 plus 2 divided by x plus 2 divided by x squared. Now what I'm going to do here is I'm actually going to plug the value, our infinity, in for each of our x values, okay? So we're going to find this limit. That looks like an 8. I don't do this very well. Got to stick my tongue out to do it. Okay, we're going to actually plug that value in. So as we put in our limit, we have 3 minus 5, and we'll do it in red here. I'm just going to do them all at once. Divided by 5 plus 2 divided by plus 2 divided by squared. And these values are now infinite values, okay? Well, like we talked about in the last example, if we divide a term by an infinite value, we're creating a 0. So we have 3 subtract 0 divided by. Now, here we're not dividing that term by an infinite value, so I'm going to keep this infinite value. We're technically going to be multiplying by it on the outside. Then we have 5 plus 2 divided by an infinite value is 0, and again 0. We'll simplify again. We get 3 over 5 multiplied by an infinite value. What will 5 multiplied by an infinite value be?
Infinite.
Infinite, right? So we're still going to be left with the same scenario we were before, a number divided by an infinite value, and what does that create? We talked about it. A 0. So your wonderful tricks both panned out when we proved them. Okay?